Dear cadets, good morning to you all. Hope you all are fine at your home. Due to corona pandemic, our regular classes are not taking place. So now I am here to take your class virtually. I welcome all of you in my class, and the topic is inverse trigonometric function from chapter 7 of your book. Learning outcome. After the class, the cadets will be able to explain principal value of an inverse trigonometric relation, explain formula related to inverse trigonometric function, solve inverse trigonometric function related problem. Principal value of an inverse trigonometric relation. The principal value of an inverse trigonometric relation is the value which is the numerically smallest, positive or negative, than all values. Example, the values of sine inverse half are 30 degree, 150 degree, 390 degree, etc. But the principal value of sine inverse half is 30 degree. 30 degree is numerically smallest of all the values. Remember one thing, any inverse trigonometric relation have no more one principal value, and if any trigonometric ratio, there are two numerically equal angles, one which is positive and another negative. Then for all principal values of the inverse trigonometric relation, the positive angle is to be taken. Here we can see sin inverse x is a function only this region. So the limit of the principal values minus pi by 2 less than equal to sin inverse x less than equal to pi by 2. 0 less than equal to cos inverse x less than equal to pi. Minus pi by 2 less than tan inverse x less than pi by 2. Similarly, other ratios. Now we can see. We know this about this chart. Now let us try to understand about this chart. Inverse function, sin inverse x. Range of principal value minus pi by 2, comma pi by 2. Here close intervals. Here close interval means the value of the angle including minus pi by 2 to pi by 2. And open interval does not include the end point. That means greater than minus pi by 2 and less than pi by 2. Similarly, others. Now we prove formula. Prove that sin inverse x plus sin inverse y is equal to sin inverse x root 1 minus y square plus y root 1 minus x square. Prove. Let sin inverse x equal to a. Then we can write sin a equal to x. And sin inverse y is equal to b. Then we can write sin b equal to y. We know sin a plus b equal to sin a cos b plus sin a plus cos a sin b. Here we see, we know the only sin a and sin b value. but we don't know the value of cos A and cos B. That's why we convert cos B into sin B and cos A into sin A. We know sin square A plus cos square A equal to 1. That's why we can write cos A equal to root 1 minus sin square A. Cos B is equal to root 1 minus sin square B. Now putting the value of sin A and sin B, then we can write x root 1 minus y square plus y root 1 minus x square. Therefore, we can write a plus b is equal to sin inverse x root 1 minus y square plus y root 1 minus x square. Thus, a means sin inverse x and b means sin inverse y. Now we can write sin inverse x plus sin inverse y equal to sin inverse x root 1 minus y square plus y root 1 minus x square. Proved. Similarly, we can prove that sin inverse x minus sin inverse y equal to sin inverse x root 1 minus y square minus y root 1 minus x square. Another formula, prove that cos inverse x plus cos inverse y equal to cos inverse xy minus root 1 minus x square into 1 minus y square. Prove. Let cos inverse x equal to a. Then we can write cos a equal to x and cos inverse y equal to b. Then we can write cos b equal to y. We know cos a plus b equal to cos a cos b minus sin a sin b. But we know only the value of cos a and cos b. That's why we can convert sin a and sin b to cos a cos b. We know sin a is equal to root 1 minus cos square a. Sin b is equal to root 1 minus cos square b because sin square a plus cos square a equal to 1. Now putting this value, then we can write xy minus root 1 minus x square into 1 minus y square. Therefore, a plus b is equal to cos inverse xy minus root 1 minus x square into 1 minus y square. Here a means cos inverse x and b means cos inverse y. Putting this value here, then we can write cos inverse x plus cos inverse y equal to cos inverse xy minus root 1 minus x square into 1 minus y square. Proof. Similarly, we can prove that cos inverse x minus cos inverse y equal to cos inverse xy plus root 1 minus x square into 1 minus y square. Now we solve some problems. Sin inverse root 2 sin theta minus cos inverse root cos 2 theta equal to 0. Left hand side. Sin inverse root 2 sin theta minus cos inverse root cos 2 theta. We know cos inverse x equal to sin inverse root 1 minus xy, 1 minus x square. That's why we can write cos inverse is equal to sin inverse 1 minus x square. X square means root cos 2 theta, root cos 2 theta whole square. Then sin inverse root 2 sin theta minus sin inverse 1 root square cancel. Then we can write cos 2 theta. We know 1 minus cos 2 theta is equal to 2 sin square theta. Then we can write root 2 square root cancel, then sin theta. Yes, sin inverse root 2 sin theta minus sin inverse root 2 sin theta is equal to 0. Proof. Now another question. Prove that tan 2 tan inverse x is equal to 2 tan inverse x plus tan inverse x cube. Proof. On right hand side. Equal to 2 tan inverse x plus tan inverse x cube. We know tan inverse x plus tan inverse y is equal to tan inverse x plus y by 1 minus xy. Using this formula here, then we can write 2 tan into tan inverse x x y. Then tan inverse cancel. Then we can write 2 here x common. Then we can write 1 plus x square. Here x into x cube. That means x4. x4 means x square whole square. Then we can write a plus b into a minus b. That's why 1 plus x square into 1 minus x square. Now 1 plus x square, 1 plus x square cancel. Then we can write 2x by 1 minus x square. Now multiply tan inverse 2x 1 minus x square. Then we know tan inverse 2x by 1 minus x square is equal to 2 tan inverse x is equal to left hand side proof. Now another question. Prove that cos 2 tan inverse 1 by 7 is equal to sine 4 tan inverse half. Left hand side cos 2 tan inverse x. We know 2 tan inverse x is equal to cos inverse 1 minus x square by 1 plus x square. Now using this formula here, then we can write cos inverse 1 minus x square, x means 1 by 7 by 1 plus 1 by 7 whole square. Here cos inverse cancel. After calculating this, then we can write 48 by 50. Now dividing 2, then we can write 24 by 25. Now right hand side is equal to sine 4 tan inverse half. Here sine 2 into 2, 4 tan inverse half. We know the formula sine 2a is equal to 2 sine a cos a. Here a means 2 tan inverse half, 2 tan inverse half. Now we know 2 tan inverse x is equal to sine inverse 2x by 1 plus x square. That's why we can write 2 sine into sine inverse 2x, x means half, plus x square means half square, cos 2 tan inverse x means cos inverse 1 minus x square, x means half, by 1 plus x square. Here sine inverse cancel, cos inverse cancel. After calculating this, then we can write 24 by 25 is equal to left hand side equal to right hand side proof. Now another question. Prove that tan half sine inverse 2x by 1 plus x square plus half cos inverse 1 plus x 1 minus x square by 1 plus x square is equal to 2x by 1 minus x square. Solution. Left hand side. We know sine inverse 2x by 1 plus x square is equal to 2 tan inverse x. Here we know cos inverse 1 minus x square by 1 plus x square is equal to 2 tan inverse x. Now putting this value, tan into half into 2 tan inverse x, 2 tan inverse x, 2 cancel. Then we can write tan inverse x plus tan inverse x, 2 tan inverse x. We know 2 tan inverse x is equal to tan inverse 2x by 1 minus x square. Here tan cancel. then we can write 2x by 1 minus x squared. Proof. Now another question. Prove that sine cot inverse tan cos inverse x is equal to x. When you solve this type of question, always follow the previous term, and by using figure convert previous term. Now solution. Here cos inverse x. Now we try to convert cos inverse x into tan inverse x. Here cos inverse x means base by hypotenuse, x base hypotenuse 1. From Pythagoras we can write perpendicular is equal to root 1 minus x square. Then sine cot inverse tan inverse. Tan means perpendicular by base. Here perpendicular root 1 minus x square base x. Now tan inverse cancel. Then we can write sine cot inverse root 1 minus x square by x. Now again another figure. Here cot inverse root 1 minus x square by x. That means base by perpendicular. Here base root 1 minus x square and perpendicular x. From Pythagoras we can write perpendicular square plus base square. That's why after calculating this we can write x square minus 1 plus x square cancel is equal to hypotenuse 1. Then sine inverse. Here sine inverse means perpendicular by hypotenuse. Here perpendicular x and hypotenuse 1. Now sine inverse cancel. That's why we can write x. Proof. Now another question. Prove that cot inverse tan 2x plus cot inverse minus tan 3x is equal to x. Solution. Left hand side cot inverse tan 2x plus cot inverse minus tan 3x. We know cot minus theta is equal to minus cot theta. That's why you can write cot inverse tan 2x minus cot inverse tan 3x. Now we can write cot inverse cot pi by 2 minus 2x. Here pi 1 into pi by 2. That means 1 is odd number. So cot will turn into 10. Here pi by 2 minus 2x. That means first quadrant all positive. That's why we can write cot pi by 2 minus 2x is equal to tan 2x. Similarly, we can write cot pi by 2 minus 3x is equal to tan 3x. Now cot inverse cancel. Then pi by 2 minus 2x minus cot inverse cancel minus pi by 2 minus into minus is equal to plus 3x. Here pi by 2 minus pi by 2 cancel. 3x minus 2x is equal to x. Right hand side. Proof. Prove that sec square tan inverse 2 plus cosec square cot inverse 3 is equal to 15. Left hand side. Sec square tan inverse 2 plus cosec square cot inverse 3. We know sec square is equal to 1 plus tan square. and cosec square is equal to 1 plus cot square theta. Here theta means tan inverse 2, here cot inverse 3. Now we can write 1 plus 1 is equal to 2, tan inverse 2 whole square, cot inverse 3 whole square. Here tan cancel, cot inverse cancel. Then we can write 2 plus 2 square, that means 4, plus 3 square, that means 9, is equal to 15, right hand side root. Now this is your homework. Prove that sin inverse 3 by 5 plus half cos inverse 5 by 13 minus cot inverse 2 is equal to tan inverse 28 by 29. Now another question. Prove that cos inverse x is equal to 2 cos inverse root 1 plus x by 2 is equal to 2 sin inverse root 1 minus x by 2. Prove that 2 tan inverse cosec tan inverse x minus tan cot inverse x is equal to tan inverse x. That's all for today. If you have any query, you can ask that in the comment section. Lastly,